Hey everyone, today we are going to dive into an exciting project where we will explore and implement K-means clustering. So this is a powerful unsupervised machine learning algorithm and our goal is to understand how to segment data into distinct groups based on their features, which can be incredibly useful for various applications such as customer segmentation, market analysis, image compression, and many more. So, let's walk through the workflow for our K-means clustering project. First, we will clearly define what we want to achieve with clustering. This could be identifying different customer segments in a retail dataset or categorizing similar items in an inventory. Next, we will gather the relevant data and prepare it for analysis. This involves cleaning the data by handling missing values, removing duplicates, and normalizing or standardizing the features to ensure consistency. Then, we will perform exploratory data analysis to understand the data distribution and relationship. Visualizing tool like scatterplot or histogram will help us to gain insights into the data structure. After that, determining the optimal number of clusters is crucial. So we will use the elbow method, plotting the within cluster sum of squares like WCSS for different cluster numbers and identifying the elbow point where the rate of the decrease slows down. Then, with the number of clusters decided, we will initialize and feed the K-means algorithm to our data, setting the number of clusters based on our previous analysis. Lastly, visualization is a key understanding of our result, right? So, we will plot the clusters to visually inspect the separation and distribution of the data points and highlighting the cluster centroids for better clarity. So, throughout this journey, we will see how K-means clustering can transform raw data into actionable insights. So, without any further delay, let's get started. First, I'm gonna import the necessary libraries like NumPy, Pandas, Matplotlib, Seaborn. These all are necessary libraries for this project, right? So let's import it. So here I just import all the necessary libraries and to ignore the warnings, I have import the warnings library, right? Now let's import the dataset. Here I am using Colab platform. So to import the dataset, I have to go to here and then select the dataset and then open. This will upload the dataset into my Colab platform, right? And now I have to read this dataset. So for this I need to use the pandas library, right? So df is equal to pd dot read underscore csv and then mention the path of this dataset. Just click here and then copy path and into the quotation mark I have to paste the path. Now let's just see the dataset df.head and I want to see 5 rows of this dataset. Now enter. Okay, okay, I have written a wrong. Okay, okay, so here we can see we have 5 columns customer ID, gender, age, annual income, spending score. Now, let's just check the shape of the dataset. Basically, how many rows and columns do we have in this dataset, right? So for this, we have to use the shape method. df dot shape. So here we have 200 rows and 5 columns. Now let's see the information, basically info of this dataset. So for this I have to write the info method. So df dot info. So here we can see the information of this dataset. Basically we have 200 entries. It means 200 rows. We have 5 columns. And let's see the data type of the column. Customer ID is integer 64. This is okay. Then gender column, this is a categorical column, that's why this is in object format, right? This is also correct. Then age, annual income, spending score, these all are numerical columns. So here all the columns is in correct data type. Now let's check the duplicate value, right? So for this I have to write the duplicate method. So df dot duplicated and then enter. So this gives me the boolean variable, but I don't want to see like this. I want to see how many duplicate rows and columns we have in this dataset. So for this I have to mention the sum. Right, here we can see 0, means we don't have any duplicated rows in this column. Now let's check that how many null values or missing values are present in this dataset. So for this I have to write the null method. So yeah, we can see there is no missing values in our column, right? Okay. Now, as we don't have any duplicated values or null values, so we can proceed to clustering our dataset, right? So for this, I have to split the necessary columns. Basically, I want to take only this annual income column and spending score column, and these two columns I am gonna store into x variable, right? So that would be my x data set. So let's just split it out. So my variable is x is equal to df dot ilog and then all the rows and 3 and 4 columns, and I want to take the values. Okay, so now just print the x dataset. So here we can see these values are for the third column and these values are for the fourth column, right? Now let's find the WCSS values. So for this first I have to mention an empty list, which is WCSS. Now I have to write a condition from 1 to 11. Basically I want 10 points to find the elbow point, right? Now I'm gonna import the KMeans method, and into this KMeans I have to insert the parameters which is n underscore clusters and equal to I. So here n underscore clusters is equal I. This basically sets the number of clusters for the current iteration, and I changes from 1 to 1 to 10 with each iteration of the loop, right? And then let's write the parameter which is init is equal to kmeans plus plus. So this KMeans plus plus specifies the method for initializing the cluster's centers, and KMeans plus plus is a smart way of initializing the centroids to speed up the convergence, right? And last we have to write the another parameter which is random state is equal to 42. So random state is equal to 42. This basically sets a random seed to ensure the results are reproducible, right? And now let's feed the X dataset. And then append this into WCSS list, array list. WCSS dot append, then K means inertia. Dot inertia. Now we have to plot the elbow graph. So for this, I'm gonna use the set method, sns.set method. So plotting the elbow graph. So sns.set. Now I'm gonna plot the WCSS list into a graph, right? So for this, I'm gonna take the range from 1 to 11, basically 10 points, right? So yeah. And I'm gonna set a marker that would be O. Now let's set the title, plt dot title, the elbow point graph. Then plt dot x label. X label would be the number of clusters. Okay, so number of clusters, and y label would be plt dot y label. This would be WCSS. Okay, fine. Now let's print it. So plt dot show. Okay, so there shows a problem. So KMeans is not defined. Okay, we didn't import the KMeans, right? So let's import it. So from sklearn import KMeans. Okay, sklearn. This would be sklearn. Fine. Now let's run this. Okay, KMeans feed dot. What is this? KMeans instead of oh, okay. So here is our graph. In this graph we can see there is a significant drop in this point and this point. So we can take these 2 points, but we have to take only 1 point. So if we consider this point, we can see after this point we have another significant drops in this point. So we cannot take this, right? So if we take this after this point, we don't see any significant drops of the graph, right, of this line. So from this graph we can conclude this. We can take 5 as a cluster, right? Because this point is the middle point of 4 and 6, so we have to take cluster is equal 5, right? So okay, now let's train the cluster model, right? So training the cluster model. I'm gonna take this and paste it over here, and as my cluster point is 5, so I have to replace it I with 5, right? And I'm gonna take the random state is equal to 0. So random state is 0, basically this is for reproducibility, right? And this ensures the consistent results for each time the code is running, right? And then I'm gonna feed the prediction value. So KMeans dot feed underscore predict, and predict is y. So I'm gonna store this into y variable, right? And print the y variable. Print, okay, I missed it. Print y. So here we have fitted the prediction value of the x variable, right? Now let's plot the clusters and the centroids. Okay, so I'm gonna just make a text. Plotting the clusters and centroids. So now I am gonna take the figure size. So plt dot figure, and then fig size is equal to 8,8, right? Okay, so 8,8, and then I'm gonna plot the scatter plot. Okay, so plt dot scatter, and then mention the x coordinate and y coordinate. So x would be y is equal 0, 0, right? So this 0 means cluster point, and this 0 means the first column of my x dataset. Okay, and then take the y coordinate. So x of y is equal 0, 1, right? And then set, okay, so then set is equal 50. This is basically the scatter plot data point, right? and after that color would be orange, and then label label is equal to cluster 1. Now as I have 5 clusters, so I have to repeat this 4 times, right? So let's just copy this and paste it 4 times. And this portion, basically this first 0 means the cluster name, this first value means the cluster point, basically first cluster, second cluster, this, and this second values is basically the X dataset of the first column, right? So I have to change here the cluster point, which is 1, then second one would be 2, sorry, this would be third one. So in this programming we start indexing from 0. We don't count it from 1, we count it from 0, right? So 0 cluster, 1 cluster, number 2 cluster, number 3 cluster, and this would be number 4 cluster, right? And here also this would be number 1 cluster, okay, and here I have to change the color of this cluster point and the label of this cluster. Okay, I have mentioned all the cluster colors and size, basically, and labels, and now let's plot the centroids, right? So plotting the centroids. So for this I'm gonna plot plt dot scatter and then KMeans dot cluster underscore CSV. Okay, class here cluster dot centers, sorry. So and then I have to take all the rows and the 0 columns, number 1 columns, and again KMeans dot cluster and then all the rows and number 2 columns, right? Now let's put the shape of the center, which is would be 50, and color would be red, and then marker is equal star, and label L label is equal to centroids. Okay, fine. Now let's say the title. So plt dot title is equal to, so plt dot title would be customer group, okay, and then plt dot x label. I'm gonna set the x label to annual income, and then y label would be spending score. Right, now let's just check. The Okay, so I have missed the title. TI Y level. Oh, PLT dot Y level. Sorry, PLT dot Y level, and I'm gonna show this PLT dot show. Okay, so here is our scatter plot. Basically, x-axis represent the annual income and y-axis represent the spending score. So if we consider these YOLO customer groups, so here we can notice that they have high annual income but their spending score is low, right? And if we consider this magenta customer group, so this has the high annual income, also their spending score also high. So we have 5 types of customers in this data set, right? So yeah, that's it for today. We have seen K-means clustering can transform raw data into meaningful insights, and this helps us to make informed decisions and drive innovation in various fields. I hope this project has provided you with a clear understanding of K-means clustering and its practical applications. So feel free to reach out with any question or further discussion. Thank you and happy clustering!